Welcome back to Part 5 of Item Software Risk Analysis Training Series. Up to this point, we have focused on the why and how of risk assessment. We've explored the theory behind deductive and inductive modeling, analyzed our reactor vessel case study, and learned the fundamental logic gates and event types that make up a fault tree. Now, we are ready to transition from theory into the software itself. To follow along with the upcoming hands-on exercises, you will need to have the Item Toolkit installed on your machine. If you haven't done so already, you can obtain a demo version by visiting our website at itemsoft.com. Once you are on the homepage, click the Get Demo button in the navigation menu. Fill out the short registration form with your contact information. After submitting, a member of our customer support team will reach out to you via email with a link to download and install the software. Having the software open will allow you to replicate the steps we are about to take. In the next few minutes, we will launch the toolkit and begin building our reactor vessel model from the ground up. Now that you have the software installed, we are ready to move into the hands-on portion of our training. In this section, we will explore the Item Toolkit environment and learn the fundamental steps required to build any reliability model. We aren't building our reactor vessel just yet. First, we need to understand how the software organizes data and how to navigate the workspace. When you launch Item Toolkit for the first time, the About dialog box will automatically appear on your screen. This window serves as your primary reference for viewing your license and maintenance information. The Item Toolkit is a comprehensive suite featuring 14 different modules covering all aspects of reliability, safety, and risk analysis. This window provides a quick overview of your license status across the various modules and also the maintenance expiration date. Once you have reviewed these details, simply click OK to close the window and enter the main workspace. Now that we have entered the main workspace, it is important to understand how the Item Toolkit organizes your work. The software uses a clear hierarchical structure to ensure that your data remains organized, whether you are working on a simple component or a massive, multi-department facility. At the top of this hierarchy is the project. A project is the master file that acts as a container for all your analysis data. Within each project, we create systems. Systems are the organizational units that allow you to break a complex project into manageable, logical parts. What makes the Item Toolkit powerful is that a single project can contain a mix of different system types, and a fault tree system is just one of these options. Furthermore, all systems within a project can be linked together easily, allowing you to perform a truly comprehensive risk analysis across different methodologies within a single environment. To start your work, you first need to create a new project. You can do this by going to the File menu and selecting New Project, or simply by clicking the New Project button on the main toolbar. Once the project is open, adding a system is just as straightforward. To add a system into the project, simply click the system type icons located in the toolbar. To specifically add a fault tree, click the fault tree icon or select Add Fault Tree System from the menu. Now that we have entered the main workspace, let's look at how the software displays your data and where you will be performing your analysis. The interface is divided into 3 primary functional areas to keep your workflow organized. On the top left, you will find the project window. This is your primary navigation hub, displaying the system hierarchy of your current project in a clear, tree-like format. Directly below, it is the system window. This window focuses on the specific hierarchy of the system you currently have selected in the project. These 2 windows allow you to quickly toggle between different systems or open multiple projects simultaneously using the tabs along the side. The large area on the right is the main editing window. This is your primary workspace, where you can interact with your system data through 5 distinct views located at the bottom of the window. For this tutorial, we want to focus on building our logic visually. Let's click the Fault Tree tab at the bottom to enter the diagram view and begin our construction. Now, let's focus on the Fault Tree view, which is the graphical area where you physically construct and visualize the logic of your model. As you can see in the workspace, every new fault tree automatically begins with a default top gate already in place to get you started. To customize this starting point, you can simply double-click the gate symbol on the canvas to open the Fault Tree Gate Parameters dialog. This window serves as the control center for that specific gate. From here, you can update the name and description to match your case study, or modify technical fields such as the part number, LCN, and reference ID. You can also use the drop-down menu to change the gate type if your logical requirements evolve. Now, returning to our example, we will define the scope of our analysis as the vessel explosion. We can modify the default top gate by changing its name to reactor vessel explosion and its description to failure to protect against reactor vessel. While the specific type of gate you choose will depend on the logic of your analysis, we will leave this as the default or gate for now. Once you click OK, your changes are applied and saved within the project file. We are now fully prepared to use the fault tree module to analyze the reactor vessel example in the next section. That concludes our introduction to the item toolkit interface. In this part, we've covered the essential steps to get you started, from installing the demo version to navigating the initial about dialog. We explored the core organizational structure of projects and systems and familiarized ourselves with the workspace layout, including the project and system windows on the left and the main editing window with its various viewing options. We also took our first practical step by accessing the fault tree view and customizing the default top gate. By defining our scope as reactor vessel explosion, we have laid the foundation for our logic model. Now that you are comfortable with the software environment and basic gate parameters, we are ready to move from preparation to production. In Part 6, we will begin the full construction of the fault tree for our reactor vessel case study, building out the detailed logic levels we identified in our previous analysis. Thank you for watching, and I'll see you in the next section.